Hello everyone, welcome back to Math Bison. If you are in the grades 3 and upwards, maybe say 12, and quantitative reasoning feels like your biggest enemy, this video is your game changer. Today, I'm giving you a complete, a step-by-step system to fix and master quantitative reasoning. This isn't random tips. It's a logical roadmap that builds from basic to advanced with the best methods top students are using to win in their corners. By the end, you're going to be thinking like a math genius, which you are. Hit that like button, subscribe, share the video if you are ready to level up. Subscribe for more study hacks. Let's dive in and enjoy a great quantitative reasoning time. Welcome back once again. First of all, quant is just simply your ability to understand numbers. Your ability to understand numbers, and what else? You should be able to spot patterns. Patterns spotting is everything in quantitative. And you should be able to solve real world problems using math and make smart decisions. You see, something funny about quant is that there is no formula that is readily available for you to use in working out solutions. If you're looking for the area of a triangle, it is easy for you to say half base times height, half of the value of the base multiplied by the height, and you get your answer. But in quant, there are no such formula. You have to sit, think through it, and create a very suitable formula that can help you to get a solution. Now, today, we're going to use a sample from, or we take few samples from the National Common Entrance Examination from Nigeria. And I'm going to pick a few questions from there. We look at the sample, and as we go through it together, I'm going to show you the very best ways and approaches and the key things you must pay attention to if you want to get ahead in your quant. The first sample we're going to look at as sample A. In sample A, we have these cute circular objects. And we have 3 of these. Usually you're given more than one just for you to be able to use the second one to confirm any pattern that comes to your mind that looks good or that looks suitable for the solution. Okay, so what you need to do is that if you find anything that looks like it works, you cannot just go ahead and just conclude like that. You need to check with the second one, and you also need to check with the third one. So here we have 4, we have 2, we have 5, we have 10. In the second one, we have 16, we have 4, we have 6, we have 24. In the other one, we have 4, we have 2, we have 3, and we have 6. Now, the first thing you must always look at is to see how the diagram is flowing. If you look at it, you have 4 circles, and there's a connector, or there are connectors. There's a line connecting 4 to 2, and there's another one connecting 2 to 5, and there is another one connecting 5 to 10. A lot of time This is not a mistake. This can be the first clue that you're getting or the first clue that you are given to solving the question. You should ask yourself, why is there no connector between 4 and 5? Maybe there's no relationship between 4 and 5. So let's focus on what we can get from the way the line is flowing. Now we have 4, we have 2, we have 5, we have 10. And we have 16 here connected to 4, 4 is connected to 6, 6 is connected to 24. We have 4 connected to 2, 2 is connected to 3, and 3 is connected to 6. All right, what are the best approaches we can use to get the best of this? You see, majorly, generally, you don't want to see a quant question and the first thing you're doing is to start overthinking. Overthinking kills most scholars. Immediately they see the diagram, the mind is frozen. They are thinking, oh, this must be some very difficult task from another planet. It isn't usually like that. So the first thing you want to try is just to look at it and say, okay, try basic first. Basic operations. Basic operations. What are the basic operations? We have the add, try addition. Then if addition is not working, try subtraction. If subtraction is not doing it, then try multiplication. Try multiply. If multiplying is not doing it, then try dividing. Divide. If any of this is not working, try a combo. Then use a combo pack. A combo pack is just a mix of any of this, like putting add, addition, and combine it with what? Subtraction. Addition combined with what? Multiplication. Addition combined with division. Addition combined with division. If it's not working, try the others too. Subtraction, start with subtraction, then combine it with addition. Sometimes the order is very, very important. I may have done addition before subtraction, and this time I may try subtraction before addition. Then just continue. Subtraction, then use multiplication. Multiply. Something will work along the way. But if you use this strategic method, you are never really going to be stranded because you will not miss any step. You would have tried following the system, you would have tried the most basic things first. Now, let's try addition in this question. So we have 4. If you say 4 plus 2, 4 plus 2 is 6, and 6 plus 5 is 11. It's not 10. It's not seeming to work. Then we have 16 plus 4, and that's 20. If you add 6, you have 26. But what we have here is 24. That is not so ringing anything. 4 plus 2 is 6. 6 plus 3 is 9. This is 6 we have here. Basic addition doesn't seem to fix the problem. Now, there must be a story that works. If you subtract 4 minus 2, you have 2. 5 minus 2, you have 3. 10 minus 5, you have 5. 16 minus 4, you have 12. 6 minus 4, you have 2. Then 24 minus 6, you have 18. All of this doesn't seem to still create any story for us. So what works? Let's try multiplication. 4 times 2, 8. 8 times 5 is 40. 16 times 4, 64. Should I go? This is not working. We try a combo now. Or let's divide. 4 divided by 2 is 2. 10 divided by 5 is 2. But something seems to work here anyway. 10 divided by 5 is 2. Okay, let's try another multiplication this way. 2 times 5 is 10. That seems to tell a story. And 4 times 6, if you check with the next one, 4 times 6 is 24. Oh, that's making sense. 2 times 3 is 6. Looks like we have something going good for us. Here, 2 goes in this direction, multiplies 5, and the answer drops here as 10. In this one, 4 goes this way, multiplies 6, and the answer drops as what? 24. In this one, 4 goes, 2 times 3 will give you what? 6. Okay, seems like we have something. So usually, you try to label in your mind, you can just label every part of the diagram. I can say this is part A, B, C, D. I also have A, B, C, D. A, B, C, and D. This labeling is important because a lot of time order of operation or order of manipulation and direction is important. Direction. So it is not going to be, what do I mean? It's not okay for you to say 2 times 5 equals 10. And I will also say, oh, 10 times 5 to get 2. It doesn't work like that. Multiplication works in one direction. And if you're coming back, you can't use multiplication again. Direction is changing, operation is changing. It is part of reverse operation or reverse engineering. Reverse operation or engineering. In physics, in chemistry, we call this reversible reaction. Okay, in reversible reaction that goes both ways. It can go to the left, it can go to the right. So now let's do this. Now that we have found 2 times 5, 10, 4 times 6, 24, 2 times 3, 6. What do we do next? Now we need to find out how can we get 4, 6, and 4. And the only way, the first thing that strikes my attention is the fact that these numbers are square numbers. What do I mean by square numbers? Square numbers are perfect squares or perfect squares. Perfect squares do what? They are numbers that you have another number you can multiply by itself to give you the number in question or the given number. Like 4, you have 2 times 2. And for 16, you have 4 times 4. Four, you have 2 times 2. 16, you have 4 times 4. And you have 4 again. So I don't want to repeat 4. 2 times 2. So what is this telling us? What this is telling us is that 4 is a perfect square and 16 is a perfect square. Other perfect squares include 9, 25, 64, 121, 196, and so forth. When you have this, there's usually this idea of squares and what? Square roots. Square roots. So one of the things that prepares you for quant is that you should try and learn at least your square of numbers from 1 to 20, because that's the only way you will see a square number and be able to recognize it. Imagine if all you know is multiplication table, but you don't know square of numbers. Then you will see 4, you will see 16, you will see 4. This pattern will not strike anything to you. You probably just go ahead and start worrying too much. So here we have squares and we have square roots. And in mathematical operation, squares take you right ways, and to come back to the left, you do square roots. If you start with square roots to take you to the right, if you're coming back to the left, you use what? Squares is reverse operation. Now, so if we have 4 that is taking us to 2, it means that the square root of 4 will give us what? 2. It also means that 2 squared will give us what? 4. Where you have 16, the square root of 16 will give you 4. And if you do 4 squared, which is the square of 4, you have what? 16 again. This is interesting. Seems like we have told all the stories in this diagram. But don't get carried away. There's something you need to do before you go. This is what separates champions from champions. You see, you need to start thinking ahead. What is going to happen? What will happen if any of this part is missing? From this direction, it is clear that if we have 2 missing, we can always do square root of 2 or 4, we get 2. If 4 is missing, what do? So if part A is missing, we do the square of 2 to get 4. If 5 is missing, what do? If 10 is missing, what do? If any part of the A, B, C, D is missing, how do you go about it? This is where the real trick and where the real work begins. So let's look at some of the exercises under this pattern to see what we can learn. So in the first question, we have a question mark here. So this part D is missing. Part A is given as 1. Part B is given as 1. Part C is given as 5. But part D is missing. So how do we do it? We go back to the sample and we realize that whatever is in part B, in this case 1, if you multiply it by what? 5, it should drop the answer here for you. So 1 times 5 will give us what? 5. So it means that what we have here missing is 5. That's simple, if you ask me. So to check, if 1 times 5 gives us 5, then 5 divided by 5 will give us, which is this one now, will give us 1, and 5 divided by 1 will give us 5. So is the product and the divisor, the divided. Now let's see what happens in the next question. Number 2, you have the same diagram, but I believe that this time around another part will be missing, not the same part seen in this question. So here we have, the first part A is missing. We have 5 and we have 2, then we have 10. So what do? This brings us back to the story of squares and square roots, because we know that 5 squared will give us whatever is up there, which is 25. And from there, if you want to check, the square root of 25 must give us 5, which we have down here. So it means that what is missing here is what? 25. And as you can see, 25 is another what? Perfect square. Perfect square. It's a square number. Okay, let's find out what is happening in the third. In the third question, we have the same pattern, same diagram. Let's see what is different this time. We have 49, which is another perfect square, but here we have 7, which is true. Square root of 49 gives us 7. But here we have this question mark here in the part C, and we have this 35. So apparently, from what we found, we know that from part B going this way, you multiply by this and you get this. But remember that we also said that in the fact family, if you have 3 times 5 to give you 15, we know that 15 divided by 3 will give us 5, and 15 divided by 5 will give us 3. So based on this, if we apply this family fact and fact family idea, If we have a number 7 multiplied by a particular number to get 35, we should know that 35 divided by 7 should give us the same number. So remember what I said about reverse engineering or reverse operation. So here is multiplication, but if you're coming back trying to get anything that was part of the product, then you should be doing what? The reverse, which is division. 35 divided by 7 will give us 5. So it means that this question mark is the 5 we are looking for. So that is what is missing here. So just remember that you can only move in one direction. If you are doing the opposite direction, you have to do the reverse operation. So usually, addition takes you this way towards the right. Then to come back, you need to do subtraction. If subtraction takes you to the right, to come back, you need to do addition. Yes. And if multiplication takes you to the right, to come back, you need to do what? Division. If division takes you to the right, to come back, you do what? You do, to come back, you should do multiplication. So don't do the same operation in two directions. It's usually not okay like that. And you can just miss it. All right, thank you. So let's move to the next question, which is question number 4 for this sample. Question number 4. Question number 4. We're having the same sample. And okay, we have 36. And we have a question mark. We have 5. And we have 30. So in this one, there are two ways because we have two storylines that explain this very position B. First storyline is that we can use our square and square roots to get the answer there. And the second storyline is that we can use our product and factors to get the answer there. So what do I mean? We know that the square root of 36 should give us whatever is there. And in this case, it's going to be 6. And if we want to check whatever is here, if you square it, it should give you 36. And this is still 6. So 6 squared gives 36. Now, the other storyline is that we know that whatever is in part B, if you multiply it by 5, you should have 30. And by reverse engineering, if you multiply if you multiply by 5 to get any number by 5 to get 30, we know that to get that number, we need to do 30 divided by 5, and we have 6. So this question mark represents this number 6. So to check, 6 times 5 should give us what? 30. So the answer here is 6. Answer here is 6. All right. So that's that. So let's quickly take a look at a second sample. The second sample here will be sample B. We have this. 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 And we have this. We have this. This pattern looks like having an Olympic medal on your neck, you know. We have 1, 4, and we have 17. Here we have half, and we have 1 over 2 and a half, and here we have 3 over 8. Here we have 3, we have 5, and we have 52. All right. If you think that staring at the numbers at the diagrams will fix it, my friend, you are simply wrong. Follow the same system so that your life can be easier, so that quant can become your friend. Start with what? Basic operations. Basic operations of what? Let's start with addition. Let's check. 1 plus 4 is 5. It does not give us 17. We shouldn't be having 17. 1 plus 4 is 5, not 17. Half plus half is 1, not 3 over 8. 3 plus 5 is 8, not 52. Far from it, this addition is not working. Subtraction. Subtraction will not also work because 4 minus 1 does not give us 17. Half minus half is 0, not 3 over 8. And 5 minus 3 should be 2, not 52. Subtraction is not working, so let's check multiplication. Multiply. To multiply in this case, we're going to use 1 times 4, which is 4, not 17. Half times half is 1 over 4, not 3 over 8. 3 times 5 is 15, not 52. This is also not working. Now let's check divide. To divide, we can try 17 divided by 4. That's not making sense anyway. $52 divided by 5 is not also making sense. So it looks like we are not there yet. But somehow, we need to try something else. We need to go a bit further. We need to go higher level. And let's try another trick. This trick is going to be square of numbers. Square of numbers, will it work here? Square numbers. Square numbers. Let's see if it works. From the left side first, 1 squared gives 1. 1 squared is 1, yeah. But plus 4, so we're going to do it with combo of this. Square numbers and the other basic operations. Let's see. 1 squared is 1, but because this number is still far away, this 17 is still so high, I may want to even try 4 squares. 4 squared, and I'll have 16. And somehow, immediately I said 4 squared 16, I am seeing that 1 plus 16 can actually give me 17. But is this the case? Is this the story that the pattern is telling us? For us to know, we have to check with this. So half squared will give us 1 over 4, and half squared will give us another half squared will give us same 1 over 4. If you add this, you're going to have 1 over 2 again. This is not what we want because this is 3 over 8. So it worked here in the first one, and it is not working in the second one. Let's try 3 squared and 5 squared. We have 9, then we have 25, and this is going to be what? 34 instead of 52. So you see, this is why you need to pay keen attention. You don't want to have a pattern, something works for the first diagram, and you're like, whoa, I found it. Then you start using it, and the next thing, you are confused totally. And a very good exam, a standardized exam, even the wrong patterns may work in the answer sometimes with a little bit of a hole or a trap that you're just going to walk into if you're not careful. So what you need to do here is to try something else. I'm going to try cubes and cube roots. Cubes and cube roots. This happens a lot of times. Squares and cubes, cubes and cube roots. This is actually the part that really separates, the champions from the champions. You need to also learn a few cubes, number cubes or cubed numbers like 8, 27 and 64 and they're about 125. Now, let's see one cube. Something is coming to me with plus 4. Should I use the cube? No. 64 will not work here because um, it's more than 17. So let's try squared. You're going to see that 1 cube is 1 and 4 squared is what? 16. And if you add it, you have 17. You see another thing, another story that is working for this first diagram. Let's see if this also works for the second diagram. So you have half cubed, okay, and you have another half and it's cubed. It's squared this time. So how do we go? The next thing is half cubed is just half times half times half, and this gives you 1 over 8. And where you have half squared is just 1 over 2 times 1 over 2, and this gives you what? 1 over 4. So let's check if the two answers from here and there can give us what you are looking for. So 1 over 8 plus 1 over 4, you should have 8. 1 times 1, which is 1, plus 4 here is 2. Then what's that? 2. And your final answer should be having 3 over 8. This is perfect. So this one has worked for the first diagram and second diagram. So let's look at the third one. If it works for the third one, then I think we found the code. Now we have 3 cubed plus 5 squared. 3 cubed from 5 squared, you're going to have 27, because 3 times 3 times 3 is 27, and 5 squared is what? 25. 5 times 5, which is 25. So we have 27 plus what? 25. If you add this together, you should have 52. That's perfect. So we found the answer to this. So look how using the systematic approach, this system of following this pattern of basic operations, combo of basic operations, then trying square of numbers, cube of numbers, square roots, cube roots, and even a combo plus kind of idea, combo plus. Just saying, okay, what about if you combine your cubes and your squares? What can you make out of it? This is something great. All right, let's look at a few examples, a few exercises on this sample exercise. All right, the first question here is we have 1, 4, and 17. No, that's not. First question is a question mark and a 9, and we have 82. A question mark. Hold on. We have a question mark. We have a 9 and 82. So what do we do here? So we know that at this question mark, the number that's going to be there is going to be a cube number. Okay, And 9 is already a square number because 3 times 3 gives us 9. So 82, how to manipulate 82 and 9 to give us a number that would be the cube of it would add up to, we add up with 9 and the square of 9. Is that what we're talking about? Yes, the square of 9. The square of 9 and the cube of this number should give us what? 82. Now, if I say this cube and you add 9 squared and you're going to have 82, by reverse engineering, we know that this plus 81 is 82. Then if you're doing reverse engineering, if you add 18 to 81 to get 82, you should be subtracting 81 when you're coming back. So you have 82 minus 81 and you get what? 1. This cube should give us 1. And that number that can do that is 1 times 1 times 1. That can give you 1. So 1 cubed is 1, right? So this you are looking for is 1. So here is 1. Now, let's try number 2. The next one is same diagram. And this time around, we have our question mark is here, and we have 2 and we have 7. This one is easier because all we need to do is what? 2 raised to the power 3, the cube of 2, plus 7 squared should give us whatever is there. 3 cubed is 8, and 7 squared is 49. And your answer should be what? 57. 57 is correct. So here is 57. Now, let's try the last one on this sample, last pattern on this sample. The last pattern will be 4 here, and you have your question mark here, and in this part, which is part B, 89. So what is happening is that 4 cubed multiplied by, added to whatever is here, if we square it, we should have what? 89. But remember that 4 cubed is what? Plus this is 89. 4 cubed is 64, which is 4 times 4 times 4. 4 cubed. 4 times 4 times 4. And we have 16 times 4, which is what? 64. If you add it to the square of this, you should have 89. So by reverse engineering, if I do this, I should have what? 89 minus 64. This is going to be 25. There's a number, I square it, and it gives me 25. The only number that can happen like that is 5 times 5, 25. So it is the square of 5 that can give you 25. That number you're looking for is actually 5. So here is going to be 5. That's what we are looking for. So if you test it, 4 cubed plus 5 squared, we have 89. 64 plus 25, 89. 89 equals 89. Left hand side equals right hand side. This is perfect. So this is where we are stopping today. We continue in our next video. Please subscribe and share, like our videos, and encourage us as we do bring more content to help you, our champions. So Quant is easy. We continue in our next video. Thank you.